Hey, Dr. Ko, let's talk about the dam problem. So we have a dam with a water level at height little h, and the dam is height big H. We're going to set P ATM equal to 0, gauge pressure, and we're going to say that the density of water is constant. The water exerts a force on the dam wall, and that's F, and that would be equal to pressure times area. Pressure is equal to rho g y, because this is the y-axis. This will be y equals 0, and this will be y equals little h. Now, in this case, area would be the width times the height. The change in force would be equal to rho g y times the change in area, and the change in area is the width times the change in y direction. That means dF is equal to rho gy times w dy. So now we need to find what w with respect to y is. Our dam wall is a trapezoid. That's going to cut it in half. The whole wall is big H tall, but the area where the water touches is just little h tall. So this side is b over 2 because we cut it in half, and this side is t over 2, which makes this length right here t minus b over 2. Now let's solve for this length right here, which is a. This will help us get something later on. With similar triangles, we could say a over little h is equal to t minus b over 2 over big H. Now with a smaller trapezoid, this would be y I for any y distance away from y equals 0. This is y equals little h. And we want to find the width of this wi. That would be this line right here along any yi. That would be wi is equal to 2 times b over 2 plus little b, which is what we're going to call this distance right here, because it's b over 2 plus whatever this distance is, times 2 because we cut it in half. So now we need to find what b is equal to, using similar triangles again and calling this little h minus yi, this distance right here. We can say that b over yi, or b over h minus yi is equal to a, which is solving for a in this, we get little h over big H times t minus b over 2, and that would be over little h. Now we want to solve for b because we want this little b right here. So b, after we solve for b, we get b is equal to 1 minus yi over little h times little h over big H times t minus b over 2. After we get this, we want to plug it back into the wi equation, and we get b plus 2 times 1 minus yi over h, little h, times h over h, the 2 h's minus t minus b over 2. Now we want to plug this into our change in force equation, and that will give us the change in force is equal to density times gravity times y times b plus 2 1 minus yi over h, little h, times little h over big H times t minus b over 2 dy. Now that we have this, we can integrate both sides. The first side will be integrated from 0 to fx total, and the second side, this side will be integrated from 0 to little h, because that's the height of the water. After we plug this into Wolfram alpha, we get the fx total is equal to the expression b times h squared over, that's little h, over 2 plus h cubed over 6 times big H times t minus b. This is the expression for the total force in the x direction on the dam wall in terms of b for the base of the trapezoid, t for the top of the trapezoid, little h for the height of the water, and big H for the height of the dam wall.